Hello, Johanna Collins. I'm a regional design architect with Parkinson Well, and I wanted to start my presentation with a nod to Janine Benyus with a quote I came across and I thought was really appropriate for our for the work that we do. This time, we come not to learn about nature so that we might circumvent or control her, but to learn from nature, so that we might fit in at last and for good on the earth from which we sprang. So, the place, the Sonoran Desert, is really a beautiful place, and I've learned to love it, when I lived in Phoenix, Arizona. It provides a habitat for a lot of desert-adapted species. But because Phoenix, in the metropolitan area, is one of the fastest growing in the United States, their habitat is getting lost and ecosystems are being altered and destroyed. In addition, because we're building more, we're adding more concrete and brick, materials with high heat storage capacity, which causes higher nighttime temperatures, which is the reason for the urban heat island effect. And so as a result, summers are getting longer, they're getting hotter, there's less rain, and it's making survival in Phoenix and Scottsdale, the metropolitan area, more challenging and difficult. And so, the question that I ask myself is how would you design in a way that we would mitigate urban heat island effect and grow and dwell in a city in a life positive way? Because the climate is getting more extreme, there's less access to nature, the cooling relief, the respite, opportunities for urban agriculture, for people. And so it makes the place less livable, not just for us, but also the species. So in order to meet my goal, the design needs to be adapted to its context. So it needs to take into account water scarcity, the intense solar radiation, but also has to be economically feasible for developers to make this real. And so incorporating cost-effective strategies is also key. So some of the, non-negotiable parameters, my North Star, if you will, were restoring habitat, adapt to the desert environment, which means hot and low humidity, and actively cool air at night, be water sensitive, and have a low operational cost. Some of the negotiable parameters, some of the nice have opportunities would be to have a place to grow food, so urban agriculture, have a low capital cost, and provide a magical experience. So I've looked at a handful of models, and the three natural models that I've decided to use for my design are the thylakoid structures, the grana, the native desert mesquite tree bark, and the Apache cicada. The chloroplast, as a way to help create a solution that is lowering overall ambient air temperature, but also converts sunlight into energy, which is one of the functions of the chloroplast. The tree bark, the native mesquite tree bark, as an inspiration for a heat adaptive surface. So thinking about our envelope, how do we design a responsive envelope? And the Apache cicada as a way to incorporate evaporative cooling as a cooling strategy for the building. So, when looking at the thylakoid structures, they're sort of, stacks of coins, similar to stacks of coins. They're connected with bridges. And, as some of you might know the chloroplast thylakoids is also where, energy gets converted or sunlight gets converted into energy. And so basically it creates, it's a system within itself that's conducive to life and powers all life on Earth for that matter. The desert mesquite tree, has the key thing here is that there are multiple layers. It can absorb moisture. There's peaks and valleys, and so what that does, it creates convective movement in between the layers and along the facade, ultimately cooling the tree and protecting it from heat getting to the core of it. And the Apache cicada, the key there is that it siphons water from the tree and then routes it to the surface. And so how can we use a process of extracting water to encourage evaporative cooling? So my design solution, the first thing I wanted to do is look at the shape itself. We tend to build square and rectangular buildings, but when we think about building in a hot air climate, really we should be looking at building round buildings because it eliminates the surface area with respect to volume, therefore less area to heat up. Then the next thing we should do is looking at the tree. as an inspiration, create ridges and valleys or peaks and valleys to create the self-shading effect and encourage the convective cycle along the facade. And to bring in yet to another level, also looking at elevating buildings off the ground and carving out a courtyard, if you will, in the middle, which would encourage the convective air movement also within the structure. And so that as a cooling mechanism in terms of shape optimization would be step one. Then when we've optimized the shape, the next step would be to, similar to the chloroplast, incorporating building integrated photovoltaics would allow to convert sunlight into energy. And by creating, a tree-inspired, if you will, a bark-inspired facade with peaks and valleys and ridges, you're also cooling the exterior through a convective air movement. The opportunity, because we've lifted the building and now have piled foundations, the opportunity that we're creating too is to root the buildings in their place, similar to a tree, and use Earth's constant temperature to help us maintain in the interior air temperature of the building as well. So really sort of rooted in its place. Then when we think about restoring habitat, because we've liberated the ground plane, now we've created opportunities for connection to nature, urban agriculture, also that respite and cooling effect within this, hot environment. There's also opportunities on the fifth facade, on the roof, for urban agriculture, or simply habitat restoration for pollinators and birds. The other opportunities in those valleys, now we have protected environments that are self-shading. There are opportunity for vertical gardens. And so those vertical gardens could be watered through condensate water. And so similar to the cicada, the condensate water gets extracted from the HVAC units. And then through irrigation, encourage evaporative cooling the facade in addition. So now thinking about, taking the structures and replicating them in a, complex application, if you will, each structure could then collect its own rainwater. By incorporating a district-wide water treatment facility, we can treat the rainwater and reuse it on site. We can also collect black water, treat it on site, and reuse it. And the benefit of doing that as well is not only is it water sensitive, but now we've got compost. And so, we have that nutrient-rich materials that can now go back into our urban agriculture, closing that loop. Because we have chlorophyll-rich material, now we're also cleaning our air as well. So, this solution does not only cool the ambient air around it, it cleans the air, it's water sensitive, it creates its own energy, and is conducive to for all life to thrive. The other benefit is that, it could be modular, which would add that, components, that cost-effective component for developers. This is just a snippet showing what this might look like. It's definitely 3/4 baked. There's a lot of opportunities for refinement, but ultimately what you can see is that, we're creating in those valleys, we're creating opportunities for respite and kind of that protected little microclimate for people to be with evaporative cooling. We're restoring habitat on the fifth facade, on the roof, as well as on the ground plane, opportunities for wetlands and stormwater mitigation. And the Blackwater Treatment Facility could also be a community center, which would bring residents together and create a human connection as well. So the key insights for me were, when I first started, my thought was to design a green roof solution, which is just a very small part of the final solution. And so I think that biomimicry really is a way to encourage us to think at a systems level. And to me as an architect, that really is the key when we think about creating resilient cities and resilient places for all life to thrive. So the next step for me is, in addition to keep refining the design, share it with my team and the firm, and really see how could we use biomimicry as a tool and a gateway in creating really innovative solutions that are good for all living beings. So I hope we stay connected, and same shout out to Yuma and Mel. Michelle, my co-pilot. So it's been fun. It's been challenging. It's been fun, and this is just the beginning. So thank you.